Welcome. In this video, we'll take a look at an indefinite integral. Let's just remind ourselves of the components of an integral in general. Whenever we write an indefinite integral, we'll always have an integral sign, a function to integrate, and a differential. So that differential always has to have that same variable of our function. And what this is asking is it's asking to say what is the antiderivative of the function f. In other words, we're solving for capital F of x, the antiderivative. So let's take a minute to go term by term. When we take an antiderivative of a function with sums and differences, we'll just want to go to each individual term and take their antiderivative. So we'll start from left to right here. Taking the antiderivative with respect to x, we would say that this first term is going to be 6x. And to take an antiderivative, I need to raise the power of the exponent by 1. So that would be 6 plus 1 is 6, or 5 plus 1 is 6, divide by my new power, which is 6. So that is my first term. Clearly, we can divide those 6's, and that first term just becomes an x to the 6th. We'll next have negative 5. We'll have x raised to the 3 plus 1 is 4. Divide by my new power is 4. The next term is 12x, so we'll rewrite our constant, our variable, raised to the 1 right now. If I add 1 to that, that'll be x squared, and we'll divide by 2. We'll see that this term we can actually reduce as we go here is 6 and 1. We'll rewrite that later. And then the last term is a constant. Whenever I have a constant, we can imagine that there's really an x to the 0 hanging out beside it. And so we want to raise the power by 1. That would be a minus 10 x to the first power divided by 1. That'll just stay as 10 to the 10x. And then with any indefinite integral, we want to add a constant plus c so that we can describe all antiderivatives of the original function. So let's rewrite this one a little bit more cleanly. We have x to the 6th minus 5 x to the 4th over 4 plus 6x squared minus 10x, and then our plus constant c. Really important that we have that for all of our indefinite integrals. And this is our result. That would be our antiderivative, or represent all antiderivatives of the original function. Hope this is helpful. I'll see you in the next example.